And it's exciting that we're all joined together all over the world. And it's an honor for me to talk to you. I'm based in Washington, D.C. The weather here is wet, which I think is very appropriate. You know, marine biologists like to be wet, so there you go. I'm going to start my presentation and share my screen for you, and we'll get on with it. There should be time for some questions and answers, and I definitely hear what you all have to say, and I think Lorraine and Manju agree with that.
Yes.
So give me 1 second, and here we are. So hopefully you can all see my screen. I'm president of Ocean Doctor, which is a nonprofit NGO here in Washington, D.C., focused on ocean conservation. And I'm also a fellow educator. I'm a professor at Johns Hopkins University. And I last fall taught the first class on ocean sustainability. And it was a great, great class, great students. And you'll see some of them in a few moments. Last fall taught the first class on oceans. Okay, hang on just a second. My screen is frozen. There we go. So this is a synagogue in Philadelphia. And 100 years ago, I was bar mitzvahed here. And what's interesting about the people who've designed these huge structures, whether it's a church or a mosque or a synagogue or any of worship, is you enter a building like that and you feel small. And yet at the same time, you feel connected to something larger than just yourself. And I can't help drawing the parallel between the oceans, like when I'm piloting a tiny sub underwater, and those structures. You feel small, but at the same time, you feel connected to something big and magnificent. And we are just scratching the surface of understanding what's down under the water. This is Bob Ballard, and he told me, David, the most amazing thing I've ever discovered was not the Titanic. He was the one who discovered the Titanic. This is what was the most amazing thing he discovered. These are black smokers. That water is hotter than boiling water. It's superheated water. Plumes of hydrogen sulfide, and this is a community of tube worms, and they weren't alone. And by the way, this is thousands of feet down. A whole ecosystem around those black smokers, and this proved that life could exist without sunlight. And many of us, I certainly remember my biology teacher at school saying, life cannot exist without sunlight. Wrong. There's an example of something that we discovered, and it was fairly recently, just a couple of decades ago, 2 or 3 decades ago. And I always emphasize, every time we go in the water, we find something new. This is the deepest coral reef in North America off of the west coast of Florida, called Pulley Ridge at about 300 feet. Absolutely amazing, pulling up creatures we've never seen before, like this big blob, which you can see the antennae here, is a giant nudibranch, about the size of a dinner plate. And at the time, we believe that's new to science. I'm not sure whether it turned out that way, but very likely that it was. The Census of Marine Life, you should all get a copy of looking at that. Really unusual species that we had never discovered before. This is called playfully the Yeti crab, with a nod to the Yeti. And I always show this in my class. This deep water fish has a clear head, which is very strange. But what's even stranger is that these are not its eyes. These green things are its eyes. So here is a fish that sees through its own head. That's just strange. But again, every time we put our face in the ocean, whether it's in a sub or scuba diving, I always hear it from colleagues, always find something we've never seen before. 1983, Ronald Reagan here in the United States expanded the territory of the United States out to 200 miles, basically our exclusive economic zone, and many other countries followed suit. And what's interesting is the United States has more water than it has land. So many of our countries are actually ocean nations. We just don't think of them that way. And would really open up a new era of exploration. We were exploring space. We've done a great job of that and continue to do that. But we literally know more about the backside of the moon, we've mapped it, than we do about the bottom of the ocean. And of course, everybody probably around the world knows the name of the first person that put his foot on the moon, Neil Armstrong. And many also know the second person, Buzz Aldrin. But who knows the names of the first two submarine pilots that made it to the deepest part of the ocean in the Challenger Deep in the Marianas Trench? Probably nobody. And that's a shame. It happened in 1960. And this is how deep it was. 37, forgive me for speaking in feet. But basically, it's 1 mile deeper than Mount Everest is tall. So if you climbed to the top of Mount Everest and looked up, you would have a mile of water over your head. Very modern equipment, state of the art for the time. And there's a porthole. They get to the bottom and they look out the window, and as Sylvia Earle, a colleague and famous oceanographer, said, you know what they saw? They saw two eyes looking back. One of the pilots saw a little flat fish swimming all the way down 37,000 feet below the surface. Here is one of the pilots, Don Walsh, together with me at the Explorers Club, and the other French explorer in the foreground, Jacques Picard. So now you know the two names. The sad thing is it took more than 50 years for us to return. And of all people, James Cameron, the director of Avatar and Titanic, was the one who did it in this vertical submarine. And of course, being the 21st century, he gets to the bottom and he sends a tweet. So, but the point is, we have a lot of exploring to do. I've been lucky enough to be one of the explorers. I've piloted this submersible, the Deep Worker submersible, which goes only a fraction of the depth that they went to. 2,000 feet is the maximum depth. And I went to Alaska's Bering Sea with Greenpeace as part of a research expedition to look at deep water corals. And we dove, and somehow I became, just by the luck of the draw, the first human being to dive into the two deepest underwater canyons in the world, Pribilof Canyon and Jemchug Canyon. The latter is the largest in the world. It's basically twice as long as the Grand Canyon and 1.5 times as deep. And the last thing you'd ever imagine to find 2,000 feet below the surface in that cold water of the Bering Sea is coral, but there it is. And this coral, this type of coral, is the oldest living animal on our planet. These corals can live up to 4,000 years. It's mind-boggling when you think about it. And we were there because ships were trawling for fish, but their nets were dragging along the bottom, tearing these corals up. And Greenpeace went to map where these corals were. Now I got to the bottom and I decided I would turn the sub off just to kind of get a sense of what it's like to be in that blackness. Your eyes would never adjust. And then I saw something. I saw a little flash of light, red, and then a green one. And then I saw a white flash. All these flashes of light started to appear. There was a party going on. These guys were communicating and I couldn't understand the language. It was like a disco party. You can get up and dance if you want. But what's interesting is scientists have said that most of the world communicates using light because the largest living space on the planet is the deep ocean, which is dark. And all of these creatures, even this lanternfish, which has lights along its side, depend on light. So again, we have so much to explore about our oceans. Now, I don't expect anyone to know the name of the Oscar winner of the best documentary of 1952. If I had more time, I'd play you a clip, but it's violent and awful, and the movie poster gives you an idea. These were considered monsters, moray eels, sharks, whales, frequently called monsters. So I was horrified when I looked at this Oscar-winning documentary. But then I felt good afterwards because I realized this was in 1950, so 60 years later, decades later, we've changed our attitudes significantly about the oceans. We don't think of these dolphins as monsters. And yet, there still are some misperceptions about the oceans that persist today, and they're a problem. And one of them is that the oceans are so vast and limitless that there's nothing we puny humans could possibly do to change that. My generation grew up thinking this. We didn't ever think about ocean issues. When I ask people what they think the largest problem facing the oceans is today, a lot of people say pollution. And this is the kind of image that comes to mind. In the United States back in the 50s, and this is in the 1969, the Cuyahoga River in Ohio caught fire. Actually, it caught fire about 13 times over 100 years. This was not uncommon, but it became an icon of the seriousness of pollution. And the Clean Water Act was passed under President Nixon. And we actually did a pretty good job, our waterways.
Doctor,
I'm going to skip this.
Dr. David, sorry for interrupting.
Yes.
So we are getting some messages that some people are not waiting outside the waiting room. Just check the participant. See whether there are any people waiting.
Let's see. I've eliminated the waiting room, so people should be able to just pop in.
Yeah.
And we don't want to exclude anybody, so just give me one moment. Let me look at this.
Yeah, we are getting some messages saying that they are waiting outside.
Well, here, I do see actually, yeah, there are 4 people that I'm admitting now. So maybe I didn't do such a good job of.
Doctor, let me. I think, can you make me the so that I can take care of it?
Okay, sorry everyone, just give us a sec. We really did prepare, believe me. Give me 1 second. I'm giving you the power, man. Use it wisely. Okay, you got the power, Manjula.
Okay, good. Doctor, go ahead with the presentation now. Thank you very much.
So we did a good job of cleaning up our ways from point source pollution. But the issue today, and this is a global phenomenon, is non-point solution. It's fertilizer from our backyards. It's from the farms of the heartland. It's more insidious and more difficult to clean up. Just give me a second. I love this slide. We are obsessed with green lawns, and we pour fertilizer onto it. This is an ad from New Jersey of basically what we're doing when we fertilize our lawns. But if agriculture is probably, well, certainly is a bigger problem. And if you look at the United States, more than 44% of the United States, and even a little piece of Canada up here, drain into the Mississippi and into the Gulf of Mexico. And as a result, we have a dead zone in the Gulf of Mexico, which is the size of the state of New Jersey. You can see some of this very dramatically in this video. But that fertilizer does the same thing that it does on your lawn. It stimulates the growth of plants and algae. They grow. Bacteria break them down, and that uses oxygen. So these dead zones, and they're all over the world, have a lack of oxygen where nothing can really live. Fish need oxygen to breathe that they get from the water. So again, here's another view of that and the size of that dead zone. It's enormous. And again, they're all over the world and all over the United States. It connects to this issue that land and water are inextricably linked together. This is the Everglades, Florida Everglades. I used to be co-chair of the Everglades Coalition, working on restoring the Everglades. And this was a slow-moving of water. It took months for this water to reach the ocean, and it was basically a natural filtration system. And so the Florida Bay and the Florida Keys were very healthy. Then somebody had the idea of dredging and filling the Everglades. A large hurricane had come through, killed a lot of people. And so the Everglades today is a series of canals and pumping stations and doesn't resemble at all the natural flow of water that it once had. In the middle is Lake Okeechobee. They built a dam around that. That has created all sorts of awful eutrophication. This becomes very toxic. You can see this draining out into the Gulf of Mexico on the western side of Florida, and it kills basically everything that comes into its path. The other connection I wanted to raise between land and water, this is Naples, Florida, Rookery Bay National Estuarine Research Reserve. This is an estuary, and remember that estuaries depend on a very delicate balance of fresh and salt water. These are the nursery grounds for so many important species, both commercial and non-commercial. But this is a graph from last year. It looks like they didn't get any data here, but this is in July. Looks like July 1st of last year, and this is salinity. A rain event occurred, and you can see this dramatic drop. This is almost fresh water down here. We see the same thing out here. These pulses of fresh water can be very harmful to the creatures in an estuary. And the reason this is happening is we've paved over many surfaces. We've taken that slow Everglades water and we've made it fast water. And there are a lot of areas that need to be restored. There are different plant life that has moved in that needs to be restored. So ironically, very ironically, we've made fresh water a pollutant to many of our coastal ecosystems. This is Naples Bay. I've actually dove in Naples Bay, some of the most expensive real estate in the world. That bay has got too much fresh water coming into it. So now we're seeing the largest restoration in history of the Everglades and the most expensive to try to restore that flow as best we can. It will never be what it was, but I use this as maybe the poster child of how important it is, that connection between land and sea. Now, my focus, and the focus of many, has been equally, if not more, on overfishing. In the late 1800s, Thomas Henry Huxley said, the fish are inexhaustible. It would be useless to try to regulate the fishing. And I don't think he could imagine a day when Canada would declare an end to cod fishing, which were so prevalent in the northeast part of America, and the United States would follow. These populations that were so important, even as far down as the Caribbean, serving as food, they collapsed. Mm-hmm. We also saw dramatic declines of predatory fish, everything from tuna to sharks, maybe a 90% decline. But I also think Thomas Henry Huxley couldn't imagine a Russian trawler of this scale. They were fishing in little wooden boats with hook and line. And look at the scale. This is up in the Bering Sea. Look at the scale of how many fish come up with one drag of that net. Was there a question? Okay. Part of the problem also is we're still managing fish as if they're crops, maximum sustainable yield. If they're crops that we harvest from the ocean, and we forget. And I love this face. This is a red hind grouper in the Virgin Islands. These fish have jobs to do. They're not separate crops. They're part of the fabric of the ecosystem, and they play an important role. One of those roles is eating algae that can smother corals. The other problem, of course, is just the way we're fishing for fish. This is a trawl net in Mexico, and you can see it's just non-discriminate. It's ripping everything off the bottom. Here's the result of a shrimp trawl in the Gulf of Mexico. Do you see any shrimp in this photograph? I've seen it 100 times. I'm thinking maybe that's a shrimp up there, but basically, on the average, 80% of what's caught in the Gulf are small finfish. It's bycatch, and it's just tossed back into the water, much of it dead. It seems that we tolerate an enormous level of waste in the fishing industry that we wouldn't tolerate in other industries. And it's wasteful. So the way we catch fish is also an issue. So we're back to Alaska and this beautiful coral. And I mentioned the trawlers going through. And here's an example that I filmed. You can see those lines. That's where a trawl went through, ripped everything out. And basically those trawl scars go on for miles in each direction. I think that's one of the worst, if not the worst thing I've ever seen underwater. Another thing is, what kind of fish do we fish for? Mahi-mahi. They reproduce, 4 to 5 months, they're reproducing. They spawn every 2 to 3 days. They're like bunnies. It's a great fish to eat. It's sustainable. Now let's compare that. This is the spiny dogfish, a type of shark, and represents many sharks. These are common off the United States, off of the eastern side of Europe, the UK. So let's look at their life history characteristics. Well, a gestation period of 23 months, that's on par with the African elephant. And when they do reproduce, they have only 5 to 6 pups. They give live birth and they're called pups. And they don't mature sexually until 12 years. So this is like textbook, don't fish on this fish because you'll fish them out. And that's exactly what's happened with predatory fish. We've hunted about and killed 90% of many of these shark populations. The other thing I always like to talk about, they playfully call these big, old, fat, fecund female fish. or buffs. But the idea, we were all taught, if you catch a small fish, throw back, if you keep the big ones. And I'd argue that's totally backwards. You should keep the little ones and throw back the big ones, because it's exponential how many young fish a large mature fish can produce. So little by little, we're seeing more regulations that are protecting both small and large fish, which is important. So remember buffs. Another thing that's just to point out with regard to fishing, these are the Hawaiian Islands, to remind us that they're just tips of mountains, seamounts underwater. And if you look at all the seamounts around the world, there's quite a few of them. And one of the things that we're just learning about these seamounts is endemism, which means these are areas that have species that are endemic, that only exist there. You may have a species that only lives on one seamount. It's quite incredible. And the problem is, as fishing fleets move further and further offshore, they are trawling the sides of these seamounts and eliminating some of these species that may not be found anywhere else in the ocean, and eliminating them before we can discover them. Now, I know I'm depressing everybody right now, but I promise to bring you back at the end, but a little more depressing as we go along. Here's another fish you shouldn't fish for, the orange roughy. Now, you think about what an old fish is. Like 20 years, that would be an old fish, or maybe 50 years. Well, that's where they're found, but this fish, believe it or not, can live to be 250 years old. And you can see they're not even sexually mature till 23 to 40 years. So these fish are older, can be older than the United States. Would you want to eat that fish? I wouldn't.
No.
The other issue we all face is that the world oceans, 60% of them are considered high seas. They don't fall under the jurisdiction of any one country. And we've been struggling to come up with and legislation so that we can protect those areas. And we're close right now to doing that, and I'll come back to that in a second. But what I always tell people is to be really annoying when you go to a restaurant or to your fish supplier. There are tools for your iPhone, and you have all the power because you have your purse or your wallet. So you can inform yourself and ask questions. Where is this salmon from? Where is this, what species is this? And it's hard to figure out sometimes, but these are the two most powerful tools in your arsenal. There's another challenge we all have, and that's our perception of the oceans. You know, we grow up and we have our own sense of what's normal. And yet, if you look at the log of Christopher Columbus, it's dramatic. It says, drawing closer to Cuba in this way, they saw sea turtles 3 to 4 feet long in such vast numbers that they covered the sea. What? I mean, none of us can imagine this. You go out diving or on a boat, you see one sea turtle, and you come home boasting about that. Wow, I saw a sea turtle. The world has changed, eaten most of the sea turtles in the ocean. They are recovering, thank goodness, but we've lost that sense. Look at the comparison of the size of these fish, 1950s to present. And I like this, kind of sums it up here, kind of funny. These are kids that I know, kids of a fisherman I know in the islands, and they're showing their father's biggest fish that he caught that day. Do the fish look big? I mean, no, but these kids are growing up a different baseline than we have. They're thinking these are big fish because many of the big fish are fished out. So it's a phenomenon called shifting baselines. I think we've all heard plenty about climate change, so I'm going to skip over climate change. But I will talk about climate change's evil twin, which is that same carbon dioxide that is going into the atmosphere is dissolving in seawater to create carbonic acid, which eats away at anything with a calcium carbonate shell, which is just about anything that has a shell in the oceans, including corals, including all sorts of different creatures. One of the, if you've ever seen the cliffs of Dover, they're made up of coccolithophores, which are tiny plankton with frustules made out of calcium carbonate. So the fear is that ocean acidification is not only attacking seashells that we all know and find at the beach, but also attacking the very base of the food chain. And of course, plastics, I won't mention that in detail here because it's really in the news quite a bit, but I want to just at least say that just like ocean acidification, the concern is these microplastics are getting into the base of the food chain. We have issues with extinction. We had a big Save the Whales movement back in the 60s, but the whales aren't saved. And these are blue whales. They're being struck by ships. We're not hunting them anymore, thank you. But they're being struck by fish. Climate change is changing their water, and we're fishing for the food that they eat for omega-3 nutrients. So you'll see krill oil in the stores, and that affects whales and penguins and anybody else who likes to eat krill. I did some work for Biosphere 2 way back when. Now, if some of you may be too young to remember this back in the 80s, but they put 7, as they called them, biospherians into the structure to basically see if they could survive in a sealed environment for 2 years and grow their own food. They had a 1 million gallon ocean. Well, in the end, it didn't work out so well. All of the vertebrates died. All of the pollinators died, so many of the plants died. Everybody lost on the order of 20 to 30 pounds, and it was a brutal struggle. And the only things that did well in there were ants and cockroaches, and they weren't even supposed to be in there. So it was a lesson, there's one of the biospherians there, it was a lesson that things can go wrong, and when they do go wrong, things can unravel quickly. And this is where we are with many of our ecosystems. And I always like this as an example of all of a sudden, one thing leads to another, and you can literally have a collapse of an ecosystem in a very short amount of time. By the way, the guy was fine. He didn't get injured. So I became an educator at a marine science camp in the Florida camp. And this is what inspired me to become a marine biologist. This beautiful coral. This is elkhorn coral, Acropora palmata. But this is 1975. 10 years later, this is what it looked like, covered with algae. 10 years later, 10 years later, and almost 10 years later after that. You can barely tell that a reef was there. This is deeply depressing for me. One of the factors is overfishing, but there are many factors. I like your artwork, by the way. I don't know who's drawing up in there, but the average decline in the Caribbean since 1970 of corals has been more than 50%. And that figure really holds up worldwide as well. And corals are so important to our global economy for so many reasons and harbor most of the species, many of the species on our planet. But I talk about corals as the princess and the pea. They're very sensitive and fussy. Their environment needs to be just right for them. And really there are local threats and global threats. You know, the global threats we're really struggling to control, and it's going to be a while till we can control them. The local threats that you see here, nutrient pollution, which I talked about earlier, overfishing, and other things, diseases, for example. These are things that we can control on a more local level. So I've always dreamed, and many of us do, of getting in a time machine, which I guess is a DeLorean. I found a time machine, but it's a 1952 Buick, and this is Cuba, which really came to my emotional rescue. I've been working in Cuba for 20 years, and just like Havana seems frozen in time, so do those reefs. And look at how healthy this elkhorn coral looks. This is better than what I remembered in the 1970s in the Florida Keys, and it goes on like this as a barrier reef for 30 miles. It's amazing. So one of the things we're working on is to really understand why these reefs are so healthy. Don't cross out my reef. Here's brain coral. And this is a rare species of coral called pillar coral. Absolutely beautiful and healthy. So part of the reason for Cuba, and we're still doing research on this, is lower levels of coastal development. When the Soviet Union pulled out, so did fertilizers and pesticides and the finance for that. So they were forced to practice basically organic agriculture. So no or very little nutrient runoff. And recent studies show that the nutrient levels in Cuban rivers are much lower than elsewhere in the world. They also have strong environmental laws. They've protected 25% of their waters in protected areas, for example. The other thing that I find very ironic, but great, is that in their environmental laws, they require the use of environmental economics. That means putting an economic value on biological diversity and to use that information in environmental decision making. Now, for years, we've dumped whatever we wanted into the environment and taken whatever we've wanted. The environment had no value, really, in the equation. And that, this is a study by World Resources Institute. We see in Belize, the value of coral reefs and mangroves in Belize are very significant. And if you can see that graph under all the drawings on the right, the value for shrimp protection is greater than tourism and fisheries combined. So if you look at how much coral reefs reduce wave energy, it's staggering, 97%, and an 84% reduction in wave height. So if you do the economics, it's a no-brainer. If you build seawalls and concrete structures, it's 15 times more expensive than if you just restore the coral reefs and mangroves and natural ways to protect the environment. All right, let's talk about whale poop.
Doctor, just give me a second. Just give me a second. Why are you guys doing this? This is totally uncool.
Yeah.
So many people from, you know, the 50 different countries, right? 60 different countries maybe. Have you been participating?
You're messing up my well.
Don't do that. Yes, I'm just trying to, disable the settings, but I cannot do it. So please, please don't do this. I'm begging you, right? This is totally uncool. I never had that type of experience before.
Yeah, if you can erase that would help. But I'm going to keep talking because we're talking about one of my favorite subjects, which is whale poop. And if you look at the fact that the open ocean is essentially a desert, there aren't many nutrients there. Again, just like we were talking about nutrient pollution, you put some whale poop in there, it's got nutrients, and it promotes the growth of plankton. And that's sequestering carbon from our atmosphere. Then if you think about how many whales were in the years ago and multiply that, it's an enormous amount of carbon sequestration that we're not getting right now. So one of my friends and colleagues, Ralph Shami, at the International Monetary Fund, has released a study you can find online called Nature's Solution to Climate Change, where he calculates just based on carbon what the value of a whale is, just on carbon. And the answer is roughly $2 million. There was a study done in Palau that showed the value of a single shark over its lifetime to people like that photographer and other tourists is $1 million. It would be maybe $100 if you cut it up for food and sold it. And I'm proud to say my students did a student project, now evolving into a real project in the Southwest Everglades, that's Rookery Bay that I talked about earlier, to basically make help Everglades restoration pay for itself, because you're measuring the carbon that's being sequestered. We're really excited about this and very proud of my students, of course. We're doing work on Cuba's Isle of Youth. I'm just going to go through these very quickly. That's the downtown area. It's a tiny little community, very poor, but beautiful. And the idea is to provide alternatives to fishing, because many of the local areas are overfished. One of those is tourism. We haven't done such a good job with tourism in the Caribbean. We released a report, that report you just saw, in 2018. But after the decline of sugarcane, in came over the years things like this. And tourism has been very destructive. And yet tourism can be part of the solution. So part of our message is, and we were focused on, is Cuba has not developed this way and has an opportunity to develop small-scale tourism as a solution. And there's their first B&B, bed and breakfast, in Cocodolo, which is this little community. I also just briefly want to mention, Cuba just changed its constitution, and it says it includes climate change, a commitment to climate change. There are 3 countries in the world that have put this in their constitution. So that is a wonderful trend that we're seeing. And I'm going to start my close by saying we are very fortunate that people that came before us in the United States, people like Teddy Roosevelt, to create national parks, protect these beautiful areas on land. And finally, we're starting to do that in the water. President Bush here in the United States established Papahānaumokuākea Marine National Monument in Hawaii, and President Obama basically doubled the size. A Republican and a Democrat, who would have thought, agreeing on protecting corals and protecting the oceans. And the numbers are staggering. This recently came out, protect 5% more of the ocean, increase fisheries by 20%. So the idea of marine protected areas is very important. This this new high that I briefly mentioned earlier, it's been delayed because of COVID, but we're very, very close to getting this passed, and a lot of these areas will be in protected areas. Another thing that gives me inspiration is next generation aquaculture. This is in Malaysia, and these are recirculating aquaculture systems that recirculate 99% of their water. They no discharge at all, and you create an organic fish, basically. And finally, I want to talk about the next generation. I've been on a tour of all 50 US states. This is Barrow, Alaska, the northernmost settlement in North America. This is Kansas, right in the middle of North America. And this is the US Virgin Islands. That's Georgia, and I think that's Wisconsin. But the idea is to try to educate, and I know this resonates with all of you as educators, to give young people an idea that, you know, there is a lot of ocean to explore. The oceans have problems, and there are some wonderful careers, opportunities that they have. So there's the map that you can see how far I've gotten. So if anybody represents one of the states that's not yet colored in green, give me a call, and I'll head out there and we'll do this. And of course, I have to boast about my own students, who I consider the new ocean doctors, the next generation. And I think all these kids are ready to take their place in the cockpits of these submarines. I know this little girl is. And the good news is they're going to have much better stuff than we had. This is a submarine built for speed. This is Richard Branson's oceanic submarine. And then there's Iron Man. Now, believe it or not, I have Iron Man beat, because Iron Man, of course, is not real. Sorry, I hate to tell you that. Met him in Vegas. But this is a real Iron Man suit. It's called the exosuit. This is Phil Newton, who is the inventor of the sub that you saw, and this exosuit. And this is real. And this will take you to 1,000 feet if you'd like to go to 1,000 feet. And you're always at surface pressure, so you don't have to decompress. You can come up for lunch and go right back down. And his vision is to create an underwater city. So you see the black smokers, you see the deep worker, you see the Iron Man suits, and there is Captain Kirk over there for some reason. So we're lucky. A lot of the planet is still in good shape, and we have a great opportunity to keep it that way. It doesn't take much to save the planet. Education is a big part of it. Taking your kids or grandkids or your parents for a walk in nature and enjoying that, and asking a lot of questions when you go to restaurants and elsewhere, and every once in a while going to somewhere truly grand and feeling just a little bit smaller. Thank you very much.
Okay.
Manjula, I'll turn it to you.
Yes. Wait. Let me exit from the sharing screen and pin your video. Okay, great. Now everyone can ask the questions. So, Lauren, can you turn on the video so that I can pin you on the screen?
Who's got a question?
Okay.
Manjula?
Yeah.
You're in charge, man.
Yes.
If you have a question, you can put it in the chat. I'll try to answer
yes,
that.
I have enabled the chat room now so that you can, post your question to Dr. David.
I like how somebody said it was a very tiring talk, of course, corrected it to inspiring. So thank you. It was tiring for me.
Hello, doctor and everyone.
Yes.
Hi, I'm Winnie. I'm from Taiwan. Actually, I don't have a. Actually, there's a question right now. I don't have a question, but I just want to say that thank you. I really, I mean, the session was so informative. Just, I mean, it's just like a awakening session for me. Yeah, because like I mentioned, the metaphor, human are so small. Underwater, the big world, they are something we didn't know. So I really, I mean, today I was like enlightened by your speech, and there are so many evidence and like a history, the facts just in front of us. So I think today after your session is I'm an educator. I definitely will like focus on the focus of attention to protect our ocean. I just want to say thank you so much, and also I learned a lot. I didn't know the lifespan of a fish. It would took like a 20 and 30 years. So there are so many new things. It's just like in the past, we usually will like focus on the space, like a human hero exploring the space, they are hero. But there are so many things under the water we didn't know. I think they are really, and you were truly hero to me. Thank you so much. Yeah, I definitely. Yeah,
you are the educators. You are the true heroes. You are all on pedestals. So let me bow down to you. I know. I mean, I'm an educator as well, and I know how hard it is, and it's a tremendous amount of work. So let me just say, you're the heroes. I'm just lucky because I had some wonderful opportunities in my life, but I've also felt obligated to bring those experiences back and share them because it really makes it real. That's why I liked Sea Camp so much, because basically with my students, all I had to do was take them out on a boat and throw them in the water, and they led the class because they had so many questions. They were seeing things that they'd never seen before. Thank you, Winnie.
Yes, thank you so much. So I will start. Sorry, I will start like eat what the food choice. Yeah, starting from the table.
Yeah.
So what we eat.
People hate when we go out to eat because I'm always, if there's fish on the menu, I will ask them all of these questions. But if we all do it, the server will ask the cook will ask the owner will ask the supplier, and that's how the world changes. There's a great restaurant in New York. The server knew more than I. I was amazed. So I think we all have the power, again, in our smartphone and our purses and wallets, to change the world, because these guys are selling us because they're making money. And, we want to make it clear we're not going to buy fish that are not sustainable, 250 years old.
Thank you.
Please, how do I help the ocean in a big way?
Say it one more time, Hassan.
Okay, how could we help the ocean in a big way? Maybe don't using plastic or things like that will help the ocean a bit, but in a big way.
Yeah, well, what I was just talking about, I think, is the most important things. Eating the right kind of fish, eating sustainably. And that includes meat and other things as well, but especially the fish. So always ask questions about what you're eating if it's fish. You're absolutely right about plastics, and that has two sides. One is cleaning up, going to beach cleanups, but the other is trying to reduce plastic in your life. That's one of the biggest challenges. A lot of restaurants, if you do takeout, they're serving you a lot of in these plastic containers and so on. So getting plastic out of your life, letting them know, I don't want my food packaged in plastic. That's really important for all of us. And the other thing is read about the oceans, watch documentaries about the oceans, get informed, because there's so much there's so much I still don't know. And your generation is going to have some great opportunities. We need you.
Good afternoon. I am Manuela from Portugal. and I want to congratulate you for what you've just shared. I'm also educator, one more, and I have a lesson, a virtual lesson for people around the world about plastic pollution, because you said something that I totally agree. Education is key in changing. If we know what the problem is, we're able to change, and we are receptive to make that change in our little changes in our life. So that's my goal, and I'm glad you agree with me with that.
I totally agree, and I think it's great that you've got this this program out there. You know, it's so frustrating for people, not just with the oceans, but all of these environmental problems. It's almost the reverse of what I said about how we puny little humans can't make a difference to harming the oceans, and it's sort of it holds true. What can I do that could actually make a difference for the oceans? And I want to encourage people, as you are, that there are things that we can do, and they may seem small, but if we're all together on it, we can make a huge difference.
Yeah, one of our mottos is little actions do matter.
Absolutely, absolutely.
Yeah, and literacy is the name of this kind of project I have. I will write it on the chat because it's a double effect. It doesn't write the at. Liter at sea.
Oh, liter at sea.
Liter at. It doesn't write it. I don't know. Let me try again. Liter sea. Oh, now it did.
There we go.
See, because we need to know about the liter at sea, but we also need literacy to know, as you mentioned, to learn about the ocean, about the problem, about everything that you just mentioned in your presentation. So thank you again.
That's great. Liter at sea, literacy. And you know, everywhere. I was shocked to see down on South Georgia Island in the subantarctic a fur seal with plastic around its neck. You know, there's nothing we could really do, but it's pervasive and it's everywhere. And you know, I think your efforts are really needed.
Yeah, I could say that because, sorry, I'm winning again. Yeah, because I just want to say it's really, the ocean topic is really just an awakening for me. I also joined menu session too. That's also amazing too. You are also, you know, the hero too. And also, I just want to add on the plastic issue. So I'm reading some like a news or channel. They're talking about the plastic island. So I just wonder that Dr. David, can you just, in your research, do you have some data about a giant plastic island? They say in the ocean, we have a giant plastic island right now.
I'm not sure. Are you talking about the Pacific Gyre and the big?
Yeah, the giant patch, plastic patch.
So it's just the way the current system works is that plastics get concentrated into this area. And if you're sailing through that area, it's alarming. That the oceans are uniformly that polluted with plastic. But it's a reminder of how much plastic is in that region. But the other thing to remember is, you know, it's a good example of how far plastics can travel. They can be vectors. In other words, exotic species, invasive species can hitch a ride on plastic and go thousands of miles and invade another place. The other thing is every year, the NOAA, the National Oceanic and Atmospheric Administration, I think it's every year, does a major cleanup in Northwest Hawaiian Islands, which is that same area that I was showing you where George Bush and Barack Obama both worked together on this large area. There's an adorable little seal called the Hawaiian monk seal, and it gets entangled because all of these fishing nets, again, because of the currents, they end up on these areas, on these islands, and they do this cleanup, and it's tons and tons of plastics and discarded fishing lines that just won't break down because they're probably propylene, they're basically plastic.
So cool.
Somebody,
I see a question in the chat. How did they make the Iron Man suit down to, and it should be 1,000 feet? It's the same principle as the submarine, and it's actually the same principle as the International Space Station or any craft. First of all, it's pressurized. It's very thick, so you are always at the same pressure inside as you are at depth. The other thing is, you saw there was a very small tank on the back. That's because the air is recirculated, like it is in a space capsule. So the carbon dioxide that you breathe out is scrubbed out of the air, and so you recirculate that air. The sub that you saw that I was piloting can stay on the bottom for 3 days if necessary. I wouldn't want to stay there for 3 days. An average dive is about 6 hours. But that's part of the technology that Phil Newton up in Vancouver has developed. And I think that's revolutionary. I don't, you can't fly in the air, but you can fly underwater. So I think that's pretty much as close as you can get to Iron Man.
Yeah, it's great. Also, swimming can feel like this, but in the ocean, it's filled with fishes and dust. It's much better.
Absolutely.
hey, Hassan, do you need to ask a question?
No, I asked it. So, I
Okay.
got my hand.
All right. So it's asking about ocean acidification. I don't know how to pronounce that word. So let me go back to chat. Laura?
Since
An interesting question, I
Sir,
guess.
as a student, the ocean level were rising continuously due to the climate change. Here in the Nepal, at every school, they do not focus on the problems. They only focus on the education systems. Only they have not programmed, they have not project, they have not done anything for this. The government should be done. Focus on it to provide the knowledge about ocean, climate change. Especially I'm focusing on the climate change because I'm doing some project on it. Due to the climate change, glacier has melting down. Everything, lands, broad camp, everything is happening in the directly. It is indirectly, directly affect on the ocean, the dust particles, plastics, materials, all over the floors, all over ocean. As a student, what can role we play and we awareness?
I could only hear, I heard most of it. I think what I would say is, again, awareness is really important. A lot of people, a lot of the decision makers, very little about this. But politically, the oceans can actually be a lot easier because there are not that many people out there on the oceans. There's some fishermen, depends sometimes oil, but politically you don't deal with nearly as many people as you might deal with trying to establish a national park in a community where there are a lot of people. The other thing, I remember giving a talk to some students in Ohio, and I said, literally, I showed them a map, and literally what you do in your own backyard affects the Gulf of Mexico, affects the oceans. You saw that map. And I think it's important to make people feel connected to the oceans because many people feel very disconnected. Something about landlocked areas, and there are many different sorts of connections that you can make. So I think emphasizing how so many of us connect to the ocean can make a difference, whether it's farms or here in the US and the UK, lawns, the subsection green lawns, and instead planting with native vegetation vegetation in many areas. The plants like to be there. You don't have to give them fertilizer. They also filter the water and slow it down, so you don't have that fast water that I was showing you from South Florida. I hope that answers your question. I apologize if I didn't hear it all.
So I am Saurav Sakal, and 17 years old in Nepal. I agree from you, Mr. David. In my country, Nepal is a landlocked country. What I can do to save the ocean? The connection between ocean and landlocked.
Yeah, and you know, that is, it's interesting because when I talk to students in the Midwest of the United States, the oceans are out of sight and out of mind. But interestingly, their love of the ocean is just as strong, if not stronger, than people I talk to on the coasts. And I think you can take advantage of that and really win hearts and minds about the ocean, since probably an issue people aren't thinking about. And there may be some issues that they can do locally, and I've talked about two of them. One is, you know, seafood gets flown into many landlocked countries. So again, asking questions and only eating sustainable seafood is important. Limiting the use of plastics. And of course, then we have the global side of that equation, which is climate change, which is a huge issue, especially for coral reefs, which I spend most of my time working on in Cuba and elsewhere in the Caribbean. Those are just a few thoughts that I have about landlocked places, but I was very inspired traveling to places, many states here in the US that are landlocked, many of them maybe marginally to the oceans, but the awareness and love of the ocean was very strong.
Thank you.
Hello. Hello, teacher. This is Mia Abhishek today from India.
Hello.
And hello, it's nice. I was hearing you and you gave wonderful information about the oceans and about the fishes too. And teacher, my question to you is that as we know that each drop counts to make the oceans. But
How to motivate other people who are not here?
yes.
Well, I think you've got a real passion that other people would really benefit from. It's not that hard. Sort of, as I said at the end of my talk, just ask questions. The people who run restaurants, who sell you fish at the market, ask them what that fish is. Where did they catch it? How did they catch it? Did they trawl for it, for example, which I saw is very destructive. And then in terms of your friends, you know, you just get people on your side by showing your passion, educating them. And I always use the example of a little girl in 5th grade or 6th grade in Atlanta, Georgia, in the United States. And she did that. She got all her friends, got parents, the community all involved to save sharks. And what happened was she connected with politicians in Washington, D.C., and it ended up as a bill on the Senate floor to stop hunting and finning of sharks. So never doubt what one person can do. And the voice of a young person, I would argue, is stronger than the voice of someone like me. Because, you know, people like here in Washington, they hear people like me all the time. blah, 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 want to save the oceans. And, of course, that does work. But hearing from a young person, we've left the earth in not such good shape for you. And I think you can really expand on that and say, look, this is my generation. And we want to grow up with the oceans in a healthy environment. So just don't be afraid to get out there and talk to your friends and parents and everybody else. And that's, show them how much you care.
Yes, exactly.
Excuse me, teacher.
Yes, go ahead.
Excuse me, teacher.
Yeah, go ahead.
Yeah.
Go ahead, Anushka.
Okay. Sir, I don't have any question, but I want to give my view on fishing. That when any human do fishing and eat any fish, anyone doesn't say that you have eat that fish and they doesn't say anything. But when a fish eat a human, we got it that on news, breaking news that a fish eat a human. So I think that should be not there. That the human eat fish. Anyone doesn't say anything. The fish also have their family members. The fish family members are also crying for them that they took out my brother, sister, mother, father. They also have their family members. But when a fish eat a human being, all the all over the world says that, oh, that fish eat that human, or that's very bad. So I think that it should there that we should not do like that. We eat fishes. That is not good. And
But go ahead.
I have seen a movie, Journey to the West. In that, a creature was there in the ocean that eat a human, and all over that place, all the persons was saying that, see, the creature eat a human, that person. But they were not watching that. There were too many fishes around that places, and they were put on the table, and they were cutting all the fishes and selling them, sold them out. I think that should be there. We should not eat the fish, and if anyone eat a fish, so it should also be showed on the news that that person has eaten the fish. So I think that should be there to protect
So-
the fishes.
That's great. And I'm not saying don't eat seafood, but some fish I would never eat again because I know too much. And some of them are my friends too. But I think you were saying something about fish eating humans. And that tends to be what you see in the news, shark attack, and we think that the oceans are deadly. I've been swimming with sharks for years. They're fascinating animals. And yes, there are shark attacks, but they are so rare. There is, believe it or not, I found the study. There's a study done in the United States that says you are more likely to be killed by a vending machine than you are by a shark. Because, if you put money into a vending machine and your candy doesn't come out, it's stuck, people rock it back and forth, and some people have died because the machine falls on top. So there's an actual study that shows that. Sharks have much more to fear from us than we do from them. We've eaten so many of them. And they, like I said, fish have an important job in the ecosystems. If you love coral reefs, for example, you have to love sharks because they maintain the population dynamics of coral reefs and make sure that those fish that can eat the algae, again, because of nutrient pollution, we have algae growing on top of coral, smothering coral. So you really need these fish to raise that algae off. And without them, the corals get smothered and die, like you saw in some of those slides. You have to love sharks. You have no choice.
Okay, it's been an hour now, so I think that we can give one chance to ask a question. Otherwise, I will ask that question from Dr. David. Anybody?
Yes, sir.
Yeah. Go ahead.
Excuse me, sir. I am very thank you for your informative class. My question is, how can we prevent ocean pollution due to plastic?
The question was about plastics. How do we reduce pollution from plastics? Or if you could repeat it a little bit.
How can we prevent ocean pollution due to plastic?
Oh, okay. Well, most ocean plastics come from land. Some comes from the oceans, primarily fishing nets. A lot of fishermen, what happens is their net may get tangled and they just cut it loose. They just cut it off. And it floats and it continues to kill fish, continues to catch fish. They call them ghost nets. And for many years because it's plastic. But one of the things we need to do is make sure buying less plastic. There's less plastic in our lives and really pushing that issue. And second, and this is more of a thing for industry, but industries that are located along the shorelines have to do a better job of making sure that plastic items from their operations aren't ending up in the waterways, and then also along rivers as well, because a storm might come along and blow all this trash and everything else out into the water. And one last thing I should mention is many municipalities around the world, including here in Washington, D.C., are coming up with a fee or a tax on bags and other plastics, which you would think might have a minimal impact, but they've been very, very successful. Here in Washington, if you use, this is my cat, hello, if you use a plastic bag, if you buy some food and they give you a plastic bag, they charge you 5 cents. And that doesn't seem like a lot of money here in the US, but it has reduced the use of plastic bags by 80% in Washington, D.C. So those are some things that people are thinking of, but it ultimately comes down to all of us thinking about it, encouraging others to use less plastic. It's harder when you get into larger industries, but you see some trends. Well, sorry, it's my, come here, Grandma, come here. Oh.
Want to say something?
He's actually a Cuban cat. I brought him back. He was found in a dumpster in Havana, and we rehabilitated him. And now he's a Cuban-American cat, and he's learning English. So he's doing well. So I hope I answered your question. There are many other thoughts about it. A lot of what's helped are symbolic things. You may see metal straws that people use and reuse and refuse in restaurants to get a plastic straw. You know, we had a guest lecturer for my class from the Plastics Coalition, and she runs the initiative on plastic straws. And she said, if we all stop using plastic straws, that's not going to change the situation. That's not the point. The point is it gives you a way to communicate to others. It gives you something to do and remind yourself and your friends. It's symbolic, but you know, if there are enough, you know, as educators, many of you, it's another form of education. It's showing your example and leading by example, and that's powerful.
teacher, I wanted to add more. You know, every year about 100 million animals die because of the plastic, and that's too much. That affects our ecosystem too. And one more thing I wanted to ask you, that you know, in our country, there the government uses the plastic bags. We used to carry the items in it, but I don't know. I don't think so that because of that we will reduce the plastic pollution. You know, everywhere there is plastic on your biscuits, cookies, or what we say, chips, and your cold drinks and your medicines. Everything is everything is it is. What will happen if we'll just stop the uses of the plastic bags? You know, whenever it is found that mostly there is the plastic of the wrappers, like of biscuits or chips or bottles are there, but the amount of plastic bags is very less. The more we should concentrate on making those, there should be some other solution to get rid of that plastic, because every item that we are using is covered with the plastic. I think we need to focus on that first.
That's great, and you can set an example in your life. And it's overwhelming, I know. See it everywhere. One of the challenges also is single-use plastic. You buy a bottle of water, you drink it, you've got this plastic bottle, and you throw it away. And there's recycling, of course, but recycling takes energy. It's not the ideal solution. So reusing plastic or having plastics, you know, plastics are great. They really do, you know, serve a purpose in our world, but single-use plastic is ridiculous. We need things that we can refill or we can reuse over and over again, and that's something that I think we can also do in our lives. I am impressed in Havana, where all of the holiday decorations for New Year's were made out of 2-liter soda bottles, you know, up on the strings and everything else. So they found a way to reuse them. They'll reuse those every year. So finding other uses for plastic is also important. But again, the problem seems overwhelming. I know you're seeing all that plastic on your